mean it is something, some simple tools which are already there and can be clubbed with NPD, and then maybe we'll see how that comes into effect. Yeah. So, node problem detector, like I mentioned, it is not a new tool. It has been around for almost close to 7 years. Ever since the Kubernetes became a familiarity, this project was already being developed under Signode Special Interest Group as part of the Kubernetes. And its main focus has already been to detect couple of node problems and make it visible to certain upstream layers. And the upstream layers here mostly refers to the Kubernetes API server, because we will be, if this tool is being used in cluster, but there are ways to use it as a systemd service. I would just show how it is being used by like how Google Cloud is leveraging it, and that is a very good example to run it as a systemd service, and how that is working. And it runs as a daemon on each node and reports problems back to the API server if it is being used in cluster, or even if it is running onto a particular host as system to service. And the main focus has always been to report the infrastructure related issues. Something like the NTP service could be down, or maybe there is a particular bug being reported into the kernel log. So it usually gets all the logs or scans all the logs from the slash tab K message, and if it sees some anomalies there, which is as per the configuration file which we have used, so it basically makes it visible as part of the node description for your worker node. You can see into the events, and as if it is coming as a permanent problem, it will come as a node condition. And if there is any hardware related issue, or there could be some issue with respect to the container runtime, maybe Docker D is getting restarted, or if it is in container D, it is getting restarted couple of times. So uh, and the last, it aligns with the remediation systems like Dscheduler, K8s, or Drano. I think most of you might be familiar with all these three projects, but just to explain, so these are something which comes one step after the node problem or any sort of problem is detected. And if you want a quick action, or maybe by the time there is a manual intervention required, if you want something to be taken care of by the automation. So we're talking about some automation after any problem is detected, and this automation could be rescheduling the pods based on the like condition not satisfied which you have mentioned in the configuration file, or if you want to issue some automated reboot of your nodes, or if you want the system CTL or the system service to be restarted by its own. So these remediation systems are basically discussed or used for that. So out of these three, Dscheduler and K8s are more popular. Drano, I think it used to be very much active before, but last couple of years it has not been used that much. So yeah, so discussing the different components of NPD. So if you see this image, so this is like my drawing, so it is not the perfect one. So this is not the official representation of the component. It is just thoughts coming out of my mind, and I try to pen it down. And so this is a representation when it is deployed as a daemon set inside a cluster, the Kubernetes cluster. And so if you see, it is the problem daemon and the exporter are the main components which is referred into the image running inside the NPD pod, and it is like sitting on a host or the worker node. And the main, so its main work is to basically detect problems going on to a worker node, right? And the communication it does after detecting those sort of anomalies, or those sort of misbehaves happening on the worker node, it basically communicates all those to the API server with the help of the problem API. And those are reported in the terms of event if it is something like a temporary happening, or if it is a permanent condition, it is termed as a node condition. And the problem daemon is, we will take a look at it in detail after this one. So in brief, it is a sub-process running inside the NPD pod, and it is classified into four types. One is the system log, system stats, custom plugin, and the health checker. So this classification is on the basis of what kind of service, or what kind of what kind of service you are just trying to monitor. So if it is a logging service or any misbehave which is reported because of NPD parsing through some particular log. So if I take example of any kernel log, so that will be classified under as log monitor. And system stats is something, it is trying to make the metrics related issues, or issues which are dragged into metrics, could be CPU or disk or memory, those sort of metrics with the help of Prometheus. If you're using Prometheus, it just makes it visible to an external backend such as Prometheus. And custom plugin is something, if you want a custom script of your own to be triggered at certain point of time with the help of NPD. Something like you're trying to track maybe NTP service which is going down, and you have some custom code written for it. So basically that monitor will be checking in that case. And health checker is something like kubelet or maybe container runtime health, you are just trying to check. The other part is the exporter. So with the help of exporter, it basically exports all the node related misbehaviors or metrics to some external backend. In terms of Kubernetes, it could be the API server, and if you're using Prometheus, so the Prometheus backend, so that you can just do some maybe with the help of PromQL, you can further analyze it and maybe integrate with the alert manager and raise some alerts. So this is the part where you may think that Prometheus is already doing a lot of it, but in some cases, if you're not using Prometheus, or if it is not configured to maybe monitor in such detail, because at the end the storage does matter for a lot of teams or the projects, how you are preserving it or how you are maintaining it. So just for a maybe something which is not being handled in too much detail, and you want NPD to look at, so it is pretty easy to get starting with. And if you're using Stackdriver, something particular to Google Cloud, so you can basically, with the help of its API, you can integrate, export the data. So talking about the problem daemon, so like I mentioned, it is a sub-process running inside the NPD pod. And when this project was initially started, the plan was to run it as a subdaemon for initial days, and maybe then separate it out as a sidecar container, so that the visibility becomes more. And if you are trying to handle some issues particular to the NPD, like there could be issues, NPD is not behaving properly, right? At the end, it's just code running inside a very big ecosystem, so that is possible. But so far, it is still continuing as a routine running inside the NPD pod. And its main job is to basically monitor different kinds of problems and report those back to the main NPD process. And then if it is something which needs immediate action, then how that is, how you have configured it at the end. And different types which I mentioned. So system log monitor, like I mentioned, it basically tracks the system logs and monitor those problems and metrics. So these could be something like K-log, or maybe file related logs, or kernel, or maybe some bug tracking, or system related issues. So I will just quickly show how the kernel monitor.json looks like. So here one thing to note is the log path is defined as a dev k message, from where NPD would basically try to look for any particular behavior or pattern which you have defined under rules. And conditions is something which comes as a permanent node condition. If you do something like a kubectl describe of a particular node, and there you will see, I will just show after that how it looks like. And the rules is something, the reason could be like out of memory killing, and pattern is how exactly the message appears into the particular log. So NPD is basically trying to identify that pattern and then raising it as maybe event, or realizing it as a node condition at the end. So yeah, like how it is mentioned for different reason and different patterns. Similarly, we have system stats monitor. So this is again, it is just trying to collect the system statistics related to memory, CPU, or disk usage, and then it is sending those to Prometheus. So it works best with external monitoring when it is used with Prometheus. And it's config.json. So this is the one. So it basically it's trying to get the CPU usage, CPU time, or maybe how many processes are running, and disk input output, and even for memory, like how much of it is used, percentage used. Oh yeah. So custom plugin, like I mentioned, if you're trying to track a particular service and you want to invoke some particular scripts for that, when as soon as the NPD detects this particular pattern, so you can basically write the custom plugin.json. So all these JSONs are the configuration files apart from the NPD what we install into a particular cluster, and we need to pass these configuration JSONs when we are just trying to bootstrap it either as a daemon set or like maybe as a systemd service. So when it runs as a systemd service, it basically uses all of these four, and then maybe you can like modify in its initial configuration if you want to add something particular to it. So health checker is when it is trying to identify the kubelet health and maybe container runtime health. So it basically uses the Kubernetes default, like there is a health checker inside Kubernetes binary, like it runs as a binary, and you can specify what kind of the different flags which are there. So yeah, so exporter is like it is also a component of NPD, which also runs as a different sub process inside it, and it basically reports all the node problems and the metrics to the backends integrated with it. So if I to take an example of Kubernetes exporter, it is just sending all these metrics or the events to the API server in the forms of events and a node condition. So events is something which is a temporary occurring. So it will come as a warning in the node description. So you may not have something like a fatal actioning happening very soon because of it, but if it persists for a longer time, like if it crosses a particular threshold, then it could be fatal, and at that time the manual, not the manual but the intervention is required, like you have automation to handle it, or if you have a cluster admin going in and then doing restart, reboot, whatever. So and the node condition is something which is permanent happening. So yeah, the Prometheus exporter is basically it is trying to like node problems and metrics locally to the Prometheus, which is configured into the cluster, and like we can specify the address and port like using the command line arguments. So these command line arguments are basically when you are trying to configure the NPD as like in couple of like config.json you can specify this. So and the stack driver is it is particular if you are only using the stack driver monitoring with Google Cloud. You can report all these node troubles via the stack driver monitoring API, and not the just not, yeah, the metrics as well. So yeah, the installation part, like I mentioned, so one way to it is pretty easy to get going with. So there is a very stable help chart being maintained by the community for NPD. You can just do a help install, and it will basically bootstrap a daemon set running like daemon set resource running inside your cluster, ensuring to monitor each and every worker node. And if you have, so by default it picks kernel and Docker monitoring, but you can just edit the values.yaml, and if you want to specify any particular config.json, so that also you can do while trying to install it. There is another way to directly apply the YAML files, similar way, but just few more steps, and you will have to create the RBAC and the config map separately, and it will also create a daemon set resource inside the cluster, just ensuring that every node is covered. The last one is pretty interesting in a way that how Google, like GKE, is using, as per my knowledge. I'm not sure if any other cloud providers are also using. So making it run as a systemd service by default for each and every worker node, and I think similar for GK as well as the Anthos clusters. So you don't have to take an overhead of installing it and maintaining as a Kubernetes resource separately, but it just runs as a systemd service, and again it is reporting things to the API server at the end, and you can see the node events and node conditions. So I have, I'll show it to you that how it basically looks like. Yeah. So for the demo part, in the interest of time, I have like two pre-recorded videos, just trying to take the fun part, not doing live demo. But the gist is to understand that how the installation happens and how the systemd part works for it. So I'll just play. Yeah. So the first part is basically how I have bootstrapped it pretty simple into a local cluster, a 3-node cluster, and we will just take a look when the pod is bootstrapped, the pod is running, how the log inside of it looks like, how it is parsing the different config.json. So currently the chart is maintained by a repo of delivery hero, but it is pretty stable and it is actively being maintained. And so here is the part where you can pass your config, custom values.yaml if you want some other configuration to be passed. So we'll just see the pods are created now, and we'll try to get the logs of any one of the pod. Yeah. So if you see at the very beginning, so it is trying to parse the log monitoring config file, and by default, like I mentioned, it uses kernel monitor.json, and it is similar to the one which I showed you in the GitHub page. So it has all the conditions and rules predefined, and below it you can see that it is beginning to start the different exporter and just trying to contact with the API server with the help of problem API. And also it is also parse the Docker monitoring.json. So at the end, yeah. So if you take a look at it, so basically you will see an error where it is mentioning that it has failed to start the problem daemon. So just to explain that there is only one problem daemon, but it is taking a look at different configuration file. So not to confuse with that, there is a separate problem daemon for maybe Docker monitoring or kernel monitoring or maybe some other file system monitoring. The problem daemon is just one. It is just looking at different configuration files. Yeah, so the error says that it has failed to start the log path where log general. Does anyone want to maybe take a guess at why this error is happening? If anyone is aware of it. No guesses. Okay, so this is a problem particular to OS related. So for some operating system, it basically picks up the logs from run log / journal, something like CentOS specific or maybe a similar operating system. But for some, the log path is mentioned as var log general. So it is just not able to parse that particular path for this particular operating system, which is running on this host. But if you change it to run log journal, it will basically start picking it up. I'll just quickly show the other one. Yep. So here I have a GKE cluster. It's a free node cluster from the free account, of course. And we just initially we see how the node description looks like when you have by default all these configs or the checks configured already. You can see at the bottom the events currently is like there are no events at present, and if we go little at the top, it will start showing different node conditions. So by default, these are the node conditions which are configured. Currently, nothing is being reported as true except the last one. And yeah, it covers all the ones which I mentioned earlier, the kernel deadlock or maybe file system related or even kubelet and Docker related. So currently there are no node conditions happening right now. And now we'll just do a quick SSH into the worker node, and we will just go through how the systemd service looks like, and we will just issue a fake error message into the kernel log and see how it intercepts into the general logs, and then it starts appearing into the node description. So yeah, it is running and active, and now we just quickly issue. Yeah, this is the error message which we will try to issue into the K message, and just basically a null pointer dereference, and so you can see here, we'll just match it with the date and time, and the latest kernel log has been reported, and the NPD service should be able to pick it up, and it should start appearing as a node under the node description as a warning. So we'll quickly do a node describe on the left side. Yeah, you can see at the bottom that it has started appearing as a warning under the events, and just we will match it with the error message we are getting on the right hand side. So so this is more like a temporary event which is happening. This will not cause any fatal unless it happens repeatedly and it is to a point that it has crossed the threshold and it is reported as a permanent node condition. So we'll quickly just move on to the last part. Yeah, so remediation systems, like I mentioned earlier, those are something which comes one step after the node has reported the problems or NPD has detected certain problems. And the very first to discuss is basically descheduler. It is a very known project now. Like many folks are using it. So it has multiple strategies to deal with. If you want to schedule and reschedule your pods into your cluster based on certain conditions. So those conditions could be something like the one which is mentioned right now. So it is called as a strategy in terms of descheduler. So one is like a remove pods violating node taints. So if it finds the pods which are violating the no schedule taints onto a particular node, it will start evicting those pods. This works something different to the automatic or like the initial node taints, which when a pod is going to be scheduled as a fresh pod onto of the worker node. So not to just confuse with the existing node taints. And if you are using the cluster autoscaler in your cluster, it will help to basically terminate that problem causing node. And once a new node is up, it will again schedule the workload back. And there is another project called K8s. It is more like a bundle of different projects, and there is a tool called Poison Pill under it, which can be used to automatically issue a reboot when it like if NPD has reported a particular problem, and you want to issue the reboot of that particular node. To fix maybe some system related or any particular issue, so that can be used, or you can maybe write your own code to issue the reload or reboot of your worker node. So Google Cloud or the GKE cluster, they are one thing which is implemented by default is if it finds with the help of NPD that Kubernetes is reporting unhealthy or maybe container services reporting is unhealthy, so it automatically issues the restart of that particular system service if it crosses the threshold value. So that is already there, but particular to GKE as per my knowledge. And Drano is another project, not active nowadays because there are different tools already which are handling that work which it used to do. Yeah. So a couple of references which I have followed in preparing this presentation, the official documentation, and there is a very good read available on how it is implemented on Anthos clusters, and maybe you can try to go through it and see if it will work or maybe fit into your project. And yeah, you can just reach out folks on the Kubernetes Slack channel for it if you have any particular issue. Yeah, so this is just a little bit if you want to stay connected with me via different social media channels. Yeah, thank you. Well, if you have any questions.
Thanks, Pravar. Pravar, very interesting topic. First of all, node problem detection is one of the key issues that we've been facing as an organization inside. But one of the things that comes to my mind immediately is some of the aspects that you have mentioned, like getting audit logs, getting access to /dev KA message, executing systemd on the target host is not possible on a lot of distributions, like Bottle Rocket, container optimized OS. In case of Google, you mentioned that there is something called as node exporter, right? And that solves the problem to some extent. But for Bottle Rocket, container optimized OS to some extent, and several other, right? How do you handle that situation where you might not have direct access to the host and you might not want to change anything at the host? Because the primary reason why they don't allow any changes at the host layer is for the compliance and audit perspective of the host. How do you handle that situation?
So I basically don't use GKE. That was just for reference. So what in my case, what we like working at IBM, working for the IKS, what we have implemented is, of course, we don't have we cannot do a very simple SSH in going into the worker host also. forget about
Right.
changing the systemd service, right?
Exactly.
So we do have an auto recovery option, which basically, if the config fails or it reports it as a failure, the first thing which we do is issue a soft reboot of a particular node. So you may think that the workload will get disturbed, but it does not affect in that case, because the clusters which I work on, those are like BM clusters, and we have a huge capacity to work on. Maybe like you're absolutely right if it is a very restrictive project, if there are too many restrictions on the Kubernetes cluster itself on the host side. So yeah, that is like an interesting thought for me, but I don't have an answer for that solution. But like there is always a scope of automation in that sense.
It makes a lot of sense for on-prem clusters, right? And
Yep.
where you have complete control over the
Yeah.
nodes.
So as an SRE, I do have access to the clusters to a level where I can go and maybe look at some files. But also there is a restriction in that sense also. Like I cannot directly go and maybe do an exec into the pod itself or SSH into it. So we have certain automation which takes care of it in terms of doing a soft reboot or maybe like reload if it requires. Very dangerous word to say, but yeah, if it requires. But the workload is like it doesn't get disturbed. It just redistributed. So
Hi, this is Abhishek. So I wanted to understand, so while designing the cluster, right, so there are so many tools which you have shown, right? So these goes and sits under the nodes, right? Yeah, so while doing it, I mean designing it, I mean we don't know how much they are hungry, and because if we designing, right, how much CPU and RAM they will utilize. So while designing, is there any parameters that we should keep this much of resources for this kind of tools and everything?
So, to be honest, the footprint of these tools is very less actually. NPD it just runs as a like if it is running as a system, it will just a binary. It won't take that much space. What I would suggest is to think of it as an add-on. So maybe you have your cluster, okay, and you are already running your workload on it, but you want to test to some extent that how can I make it better actually. So you will start using these projects as an add-on. You can start with the NPD and D scheduler and then test it out how it is working for it. Maybe don't send it to production right away, maybe in the dev environment something. But there is no specific hard limit or maybe criteria on how much resources you can already feed to them.
So if its pods are scaling, it will stay, I mean the resource requirement is the same, right?
Yeah, for these tools the requirement won't change because this is nothing like a proper monitoring solution or an end-to-end monitoring solution for your cluster need.
Okay.
So this is something to aid into an existing solutions which are already using. So like I mentioned, think of it as maybe initial step before your robust monitoring or like a very big monitoring setup is already trying to do. So maybe just to start with playing around, and then maybe you can take the decision if you really want this to stay for a while or like that.
Thanks.
Any more questions? Thank you. Thank you everyone.